the properties of finite differences. And what we're talking about here is when the x values in a data set are equally spaced, the differences of consecutive y values are called finite differences. So if we look at this table right here, what we could do is take a look at our x values, -3, -2, -1, 0, 1, 2, and 3, and we see that those are equally spaced. They're increasing by 1. And so now let's look at our y values. What are the differences in these y values? So if I take a look and if I subtract going left, right, and you could subtract the other way. And what I mean by that is here I'm going to subtract 9 minus 4 to get 5, right? Sometimes people do 4 minus 9, you get -5. It doesn't matter. You're going to get the same thing for the differences as long as you subtract in the same way for each set of data points. So now 4 minus 1 would be 3. 1 minus 0 is 1. 0 minus 1 is -1. 1 minus 4 is -3, and 4 minus 9 is -5. So what these numbers right here are called are our first differences, okay? So now we know that if our first differences are constant, that would represent a linear function. Well, in this case, they're not constant, so we know this is nonlinear. So now let's find the differences of our first differences. So 5 minus 3 is 2, 3 minus 1 is 2, 1 minus -1 would be 1 plus 1, which would be 2. -1 minus -3 would be -1 plus 3, which would also be 2. And -3 minus -5 would be -3 plus 5, which would be also 2. So now, what we see right here, these would be considered our second differences. So now our second differences are constant, okay? So that would tell me that this is a quadratic function or quadratic relation. Okay, and so we noticed that our second differences were constant there. Well, what if our third differences were constant? What if our fourth differences were constant? Well, that's what these two properties tell us here, and then we'll look at an example. It says if a polynomial function y equals f of x has degree n, then the nth differences of function values for equally spaced x values are non-zero and constant. So for the example that we just did previously, our second differences were constant. So that tells me, that kind of leads me to number 2. It says conversely, if the nth differences of equally spaced data are non-zero and constant, then the data can be represented by a polynomial function of n degree. So for the example we just looked at, our second differences were constant. And that's why I said it was a quadratic function, because a quadratic function has a degree of 2. All right, so now let's look at this example here and see what we have for our differences. So we look at our x values, they are equally spaced, 1 through 7, increasing by 1. So now let's find our differences here. Okay, so we have -4 minus -2. So -4 plus 2 would be -2. -2 minus -4, or -2 plus 4 would be +2. -4 minus -16, or -4 plus 16 would give me a 12. -16 minus -44, or -16 plus 44, and that's going to give me 28. -44 minus -94, or -44 plus 94, that'll give me 50. -94 minus -172, or -94 plus 172, and that's going to give me a 78. Okay, all right. So these are my first differences. Obviously, we can see they're not constant. So let's continue on. So -2 minus 2 would be -4. 2 minus 12 would be -10. 12 minus 28 would be -16. 28 minus 50 would be -22. And 50 minus 78 would be -28. So those are our second differences, and once again, they're not constant, okay? So let's keep going. So we know it's not a linear function, we know it's not a quadratic function. Let's find our third differences and see if it's a cubic function. So -4 minus -10, -4 plus 10, 6. -10 minus -16, or -10 plus 16, also 6. -16 minus -22, or -16 plus 22, also 6. And -22 minus -28, or -22 plus 28, also 6. So we got our third differences to be constant. And so we now know that this would be a cubic function. And so now what we can do on our calculator is we can actually use the cubic regression feature on our calculator in order to write an equation from, or write a function from this set of data. So we're going to turn the calculator on, and we are graphing essentially a scatter plot here. So we're going to go to Stat, and on Edit we're going to hit Enter, And now for L1, we're going to type in our x values. So that's 1, 2, 3, 4, 5, 6, and 7. Now I'm going to go over to my L2 values, and we're going to type in our y values. So that's -4, -2, -4, -16, -44, -94, and -172. So now I'm going to hit graph. All right, and now once I hit graph, my window is on the standard window, -10 to 10 on each axis, so we can't see anything. So we need to go to window, and we need to adjust our window. So for x, we need to be at least be able to see from 1 to 7. So we don't really need our x min to be -10. Let's just change that to 0. X max, I'll leave that at 10. I need to see for my y, -172. So let's change this to -200 to give us some space. Y max we can leave at 10 because we don't need, really we could change this to 0, right? Because we don't need anything above our x-axis. So let's hit graph, and we still don't see anything. So let's go back to y equals and make sure, look at the top of our calculator where it says plot 1. We need to go up to that and hit enter to make sure we have turned that plot, that scatter plot on. Now we hit graph and it shows up. Okay, so now we can see our scatter plot here. And so since we knew it was a cubic function, we can now go back to stat, go over to calc. We want to go down to where it says cubic reg, which stands for cubic regression, and we're going to hit enter. We have our lists that we put our x and y values in, L1 and L2, so we're going to leave those there. We're going to go down to where it says calculate and hit enter. And now it tells us what our equation should be. So now our equation should be y equals, tell me a is -1, so it's going to be -x cubed, b is 4, so plus 4x squared, c is -3, so minus 3x, and d is -4, so -4. And that would be the equation that would fit my data set. And so now what we can do is we can go back to y equals. We could actually type this equation in and watch it be graphed on our calculator. So -x cubed plus 4x squared minus 3x minus 4. And we hit graph and watch how our line goes right through those points because the calculator gave us that cubic regression equation. And that's how we can use the properties of finite differences to find what type of function our data set represents, and then also how we can use the calculator feature of cubic regression.